The Swiss partners in this project are funded by the Swiss State Secretariat for Education, Research and Innovation, SERI. On the DAC Plus train, automated train functions of the full digital freight train are tested based on the Powerline PLUS Train Backbone, PTB, communication system. PTB uses the train power line for data communication over the whole train, including the digital automatic couplers, providing seamless transmission of Ethernet between all wagons in the train. Test results showed already in 2023 that the 4 major train functions work robustly and reliably with the Powerline PLUS Train Backbone. Since then, the hard and software for the so-called new train functions Wakeup and Passive Consist Detection PCD based on the PTB were developed, then tested in the HSLU Virtual Train Lab and installed and field tested on the DAC Plus test train in June to August 2025. The basic principle behind the Wakeup and PCD functions is that a small DC voltage is applied to the train's power line. This voltage is so small that the AC-DC converters in the Wagon Consist Control Unit, CCUs, are not addressed, meaning the loads in these CCUs are not powered. For Wakeup, there's a small circuit in each wagon CCUs that detects the small DC voltage on the train's power line and then sends a signal to the wagon's power supply system to start the devices. Because the DC power signal travels throughout the entire train, all CCUs can be woken up at once. For the passive consist detection, the constant current sink principle is used, with a defined current per wagon, and the current is measured between awakened active wagons. If there is no passive consist in between, the measured current is 0. If, say, n passive consists are in between, the measured is n times the known current. In this case shown here, only consists 1 and 7 are active and the current of the 5 consists between is measured. A push-button box was implemented for operation during the tests. The green button performs the power-up of the local CCU. This can be useful when waking up a group of consists in the field without a locomotive. When the green LED lights up, it means the CCU is powered. When the white LED lights up, it means the CCU is ready, and the wake-up procedure is available to the user. By pressing the white button, the wake-up procedure is initiated and the DC signal is sent via the power line to all other CCUs. The wake-up detector of the PTB node in another CCU detects this voltage and sends the power-up signal to the wagon power supply system, upon which the CCU is powered up. When the white button stops flashing, all consists are awake. As a summary of such tests, it can be concluded: various consist configurations were tested in this way. The wake-up and passive consist detection functions worked correctly in all cases. Operationally, these functions are typically performed while the train is stationary before departure. It was also verified that the PTB data transmission is not disrupted by the new circuits. While the train is stationary, the packet error rates are 10 to the -7 to 10 to the -8, the same as before without the new train functions. In conclusion, and as the summary of field tests of train functions 2023 to 2025, it has been demonstrated that all train functions work with the PTB communication system in the real operational processes robustly and reliably. This proves that the Powerline PLUS Train Backbone PTB is a robust and reliable communication backbone for the full digital freight train, with data transmission via the train power line and only its power contacts in the E-couplers, enabling standardized Ethernet HEC 61375 communication, with lowest complexity, with more than 2 years successful tests in all operational field conditions, having achieved a TRL7 maturity, with the PTB node hardware being near to product maturity. With PTB, no extra data network is required, meaning extra cables, connectors, boxes, complexity, and thus meaning extra procurement, installation, and MRO costs.